Good day, grade 12 learners. Welcome to today's mathematics lesson. My name is Anelen Sindane. The lesson is brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center. Our lesson for today is still under the topic number patterns, sequences and series, and last week we looked at our sequences and series. Today we are going to look at our series and sigma notation. We know that mostly we are going to look at our arithmetic series and our geometric series. Some literature use the term arithmetic progression or geometric projection. Now, we are supposed to. Last week we looked at the sequences and the patterns. Today we want to understand the concept of a series. We want to derive and apply the formula for an arithmetic series. We also want to derive and apply the formula for a geometric series. We want to solve problems that involve sigma notation. We also want to understand the concept of a converging and a diverging series, which will lead us to sum to infinity. And we will also solve problems that involve the sum to infinity. Now, we are going to refer to the CAPS document on page 12 and page 40, and we also look at our grade 12 examination guidelines on page 6. You will get more details about what is going to be examined there. Our pre-knowledge, we have looked at determining the number of terms in a sequence, because for us to get the sum of a series, we need to get the number of terms in our formula. Our arithmetic and geometric sequences formula, how to find our nth term as well as to find any other value using those formulas. We'll look at the algebraic simplification and manipulation of our formula, changing the subject of the formula. We will look at literal equations, as well as we look at the laws of exponents and exponential equations. These we shall apply in helping us solve the problems. Now, I will ask us to look at our formula page. In our formula page, you will always find that we have formulae that we use for our sequences and series, and it is found in that part of our formula page. I just extracted the first part of our formula page. I did not include the whole formula page because I want us to see what can help us when we are referring to this topic of sequences and series. The quadratic formula, we use it a lot when we are supposed to solve, for example, quadratic equations, where it's not easy to factorize, but we'll encourage you to use factorization so that we save on time. Let's move on. Now, what is a series? We have looked at a sequence where we are saying our terms are separated by the semicolon. In our series, we replace the semicolon with a summation sign, which is our plus sign, or if it's a negative series, you will find the terms are separated by the subtraction sign or the negative sign. So you are summing up the terms in that particular sequence, hence it becomes a series. Now, to find the sum of n terms, we are just going to add from term number 1 up to the nth term as illustrated there. That is the sum of our series Sn, where n depicts the sum of the number of terms that are indicated there. Our n there should be a natural number. We remember that from our sequences where we said we were looking at Tn, now we are looking at Sn. Sn is for the sum, Tn is for the term number. Now, you will realize that if there's only one term, its sum will be equal to the value of the first term, which is our T1. If we are having two terms, the sum of two terms becomes term 1 plus term 2. Referring to the sequence that we are having, it will mean the sum of two terms becomes our term 1 is 3, our term 2 is 6, and our sum of two terms will be 9, and this will continue as you can see there. Now, let's try and understand this sequence. I will use the first four terms of the sequence that we are having so that we try to have a clue of what we are going to be working with. Let's say, for example, you are having a sequence, you are supposed to find the sum. Let's say you need to find S4. It's easier to find S4 because it will be term 1 plus term 2 plus term 3 plus term 4, like that. My term 1 is my 2, my term 2 is my 9, my term 3 is going to be 16, and my term 4 is going to be 23, like that. Now, if you are having fewer terms like this, you can easily punch them in a calculator and get the sum. But if it's 24 terms, 30 terms, chances of making a mistake by saying plus, 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 I know that our calculators get to a point where they will have a limited number of terms that you can punch in using the plus sign. So let's find a quick way of adding this without using a calculator. If I am to reverse the order of the terms, I write my term number 4 in the first position, and I write my second last term in the second position, and then I write term 2 under term number 3, and my first term under the fourth term, it will be 2. We want to find a way of adding these terms without using a calculator. If I check, 2 plus 23 will give me 25, plus 9 plus 16 will give me 25, 16 plus 9 will give me 25, 23 plus 2 will give me 25. I wanted the sum of those four, but I know that there's a relationship between multiplication and addition. I know I can write this statement. What I've done, I've written term number 2 twice, and I've written term 2 twice, term 3 twice, I've written term 4 twice as well. So how do I get the sum of these four terms? I can write what I have here because I have added these terms twice. I can now say that the sum of these terms, I can write it as, if I see here, I'm adding 25 plus 25 plus 25 plus 25. I'm adding 25 4 times, which is the same as saying 4 times 25. But remember, for me to get that 25, I've added these terms twice. I will divide this by 2. And the sum of 4 terms becomes this. So I'll get S4 as equal to 4 there. 2 into 4, it's 2. 2 times 25, this will give me 50. Now, if I add 2 plus 9, it gives me 11. 11 plus 16 gives me 27. 27 plus 23 will give me the sum of 50 terms. The sum of 4 terms is my 50. If I add this 2 plus 9 plus 16 plus 23, I will also get my sum as, so this is the sum of my 4 terms. Sum of my 4 terms, I'm getting 50. Now, we want to find a general rule That will help us to, for 4 terms, it's easier because you can see, you can easily add them column, add them going downwards. You are getting 25. How many terms are you having now? It's 4 times 25. But remember, you have added the terms twice, hence you divide by 2 to get the sum of 50. It's a way of adding. Now, let's say now you are supposed to add 100 terms. It means you must get all the 100 term values, you add them, reverse the order. It will take us a long time and chances of making a mistake are very high. Hence, in an arithmetic sequence or series, we can calculate the sum of n terms using the formula that we are having here, where we are saying the sum of n terms. If you check, we calculated S4. It was equal to our sum. Our S4 was given as 4 over 2. We multiplied our first term, which was 2, plus our last term, which was 23, to give us that 25. We divided by 2. We got our sum of 4 terms as 4 over 2 times our 50 here, and we, times 25, and we got our sum as 50. So our S4 was 50 there. So now we want to find a general way of adding these terms. If you check our Sn, the sum of n terms, our Sn will stand for the sum of n terms. Our n is the number of terms. Our a is the first term, and d is our constant first difference. Now, we can either use that the first formula, or we can use the second formula. And if you check, our last term is normally given by a, which is our nth term, n minus 1 times d. And you can see that a plus n times d, we are adding this to a plus the last term. It will become a plus, our last term is a plus n minus 1d, and this will give us our 2a plus n minus 1 times d, which is the same as what we are having there. But you are able to see that always we have the number of terms and we divide them by 2 to help us add. And these are the two formulae that we can use to add the sum of n terms in an arithmetic series. Now, so this formula is also given in our formula page you saw on the previous slide. It's also examinable. In an exam, you will be given that, for example, it has been examined in different question papers where you are supposed to do the derivation of the sum of n terms of an arithmetic series with a first term a and a constant difference d. You have to show that our Sn is given by n over 2, 2a plus n minus 1d, and it's normally 4 marks. You have to show the derivation of this formula. Literature has the derivation of the sum of n terms. It's up to you to decide which one is easier for you. But I will try and explain. If you check, a is our first term, that's our t1, plus our term 2, we know that it's a plus d, that's our term 3, plus that's our nth term tn, plus our t of n minus 1, our t of n minus 2. Let me try and explain this one. If we are having 27 terms, it means our n will be 27 here. 27 minus 1, it would mean this will be term 26, this will be term 27, This will be term 25. So this is a way of illustrating how we get our terms in that particular order. So we are saying it was easy with 4 terms, but if you are having a number of terms, writing all of them, it will fill up the whole page and will end up having things mixed up. So the same order I used with the 4 terms, it's what I'm using now. I write my first term under term number 1, my second term under term number 2, my third term under term number 3 in terms of A and D. I also write my nth term, which is my Tn. I will only, for my second last term, I will use Tn minus the difference, because that is how I will get the first last term. The term that is before the last term, that's what I will do. I will then reverse the order. I will write my last term under my first term, my second last term under the second term, and I will write my first term under the last term. When I add this, if you remember, when I added 2 and 23, I added 16 and 9, I added 2 and 23, I added 16 and 9 again. I got 25. They will all give us the same sum, which is the same as what we are having here. I will have my first term plus the nth term, which is my last term, my second term plus that one. That's what I will get for all the terms that I will have here. But now, I've added Sn twice, hence I'll get this as 2Sn. These I will add them and I will have n of them, which will now give me n times, remember on the 4 terms it was 4 here as my n, and the sum of the first and the last term, which gave me 25, it was 25 that was being repeated. In this case, it will be a plus Tn. From there, I want Sn, I don't want 2Sn. I will divide both sides by 2. And in place of Tn, I will then substitute with a plus n minus 1 times the constant difference. And it will give me my formula that I need for. So normally, you will get a mark for writing our sequence. We get a mark for reversing the order. We get a mark for the simplification to get that part. And then getting the final answer where we substitute, because this will always be given, that you show that this reduces to this. So we'll get a mark for the substitution there so that we get our final answer as that. And this is normally 4 marks in an exam. Now, you will take time to go through this again, and different textbooks approach this proof differently. So please choose the one that you are comfortable with. There are a number of them. Here is the second one that you can use. You are able to see that one where they are using L instead of using Tn. So you can also use that one where L is the last term minus the difference. Our last term is L. You add them, you will always get A plus L, A plus L. That's what those terms will reduce to. And then you will get 2Sn is equal to n times A plus the last term. You divide by 2, you get the formula with our last term. You substitute the last term, which is our nth term, with the value, then you get the answer there. Please, let's look at this and understand this. In an exam, the application of this formula can be asked, and the derivation as well can be asked. So we must be comfortable working with the formula. Now, let's move along. Here is an example that I would want us to look how we apply the formula. Calculate the sum of the first 30 terms of the sequence. Remember, if you are calculating the sum of the sequence, remember we said it's a sequence if terms are separated by the semicolon, and it's a series if I replace that. So I will have my first term, term 1 is 3, plus my second term, which is T2, plus my third term, which is 19, plus my fourth term, which is 27, T4. What is the first thing that we should look at? We have to get our difference. We know that already it's stated. They did not tell us that it's arithmetic, so we need to do the investigation. Term 2 minus term 1, 11 minus 3, we get 8. 19 minus 11, it's 8. 27 minus 19, it's also 8. So this, you conclude first that this is an arithmetic series because it has a constant first difference. You go to your formula page. You must be knowing the sum of n terms of an arithmetic series, which is given as Sn is equal to n over 2, 2a plus n minus 1d. So from there, our difference we have it's 8. We have shown it there. Our first term a is 3. Our n is equal to 30, which means we are calculating as 30. We quickly substitute. As 30 is equal to 30 over 2. Our first term, it's going to be 3 plus, if I check, my n is 30, so 30 minus 1 will give me, my difference is 8. 30 minus 1 will give me 29, but there is no harm in you substituting 30 minus 1 to give you the answer. We will then get the sum of our 30 terms as this will give me 15. 30 over 2 is 15. I will now have 6 plus 8 times 29. And we should get our answer as 15. Now, you don't have to simplify because your calculator has a fractional button. Just punch in 30 over 2. Substitute your 2. Your a, open another bracket, is 3. Close the bracket. Plus, you have your difference, it's 8. 30 minus 1. You press equal sign. It should give you an answer of the sum of 30 terms will give us 3,570. Normally in an exam, this will be 3 or 4 marks. Because they did not tell us, you show how you get your A and your difference. You get 1 mark. You get a mark for substitution and then for the answer. So 3 marks will suffice for this one. But if the examiner is lenient, then you will get 4. Now, we move on to the next example. Sometimes you are given a series like that one. So, we know that this is our term 1, that one is our term 2, that one is our term 3, that one is our nth term. We don't know the number of terms. So we want to calculate the sum of the following finite series. It's a series. So the first thing that we must do, we must get our constant first difference. To check, they did not specify that it's an arithmetic series. Let's check. Negative 11 minus negative 14, it will give us positive 3. Negative 8 minus negative 11, it will give us 3. This is enough to show you that it's an arithmetic series. Our first term is negative 14. Our difference is positive 3. Our series, we said it's an arithmetic series. Now, we need to first of all get the number of terms before we get the sum. So to get the number of terms, we are going to use our Tn is equal to A plus n minus 1 times D. Let's get the number of terms. Our nth term is 103 is equal to our A is negative 14 plus our difference is going to be positive 3n minus 1. We simplify this, it will give us 103 is equal to negative 14 plus 3n minus 3. This gives us negative 17. When it comes this side, it will be positive. We have 120 is equal to 3n. We get the number of terms as 40. From there, the series, we said it's arithmetic. So now we will use our Sn is equal to n over 2. I have my first term. I also have the value of my last term. So I can use that formula. So my Sn becomes 40 over 2. My first term, it's negative 14 plus my last term, which is 103. You press your calculator in place of n here. Sorry, I'll put my 40. So my sum of 40 terms becomes 40 over 2. That will give me 20. And then when I simplify negative 14 plus 103, I should get this as 89. And 20 times 89, this will give me 1,780. That's my answer there. So this one will be more than 3 marks because you must get the number of terms. It can be 5 or 6 marks in an exam situation. But let's quickly check. So we determine the number of terms, which I have done, and we get our number of terms as 40. Then we get the sum. We got the sum as 1,780, or we use 2a. Sn is equal to n over 2, 2a plus n minus 1 times d, and that will give our answer as 1,780. We move on. I will give you this activity. I will give you 6 minutes to answer A, B, and C. I will give you 6 minutes to answer A, B, and C. We can start so that we do not just be listeners. We need to practice to check if we are following or not. Let's start now. Welcome back. I hope you had a chance to just practice your skills. I know you have done this with your teachers to just consolidate and refresh your memory. Now, if you check this question for activity 1, it says calculate the sum. They've already told you that this is an arithmetic series. So you do not have to test first because you're already told. So all you need to do for A, just find your first difference. That's our term 1, that's our term 2, that's our term 3, up to 42 terms. So what do we have? Our difference, 5 minus 3, we get it as 2. So we already know our A is equal to 3. Our D is equal to 2. Our N will be equal to 42, which is the number of terms. So I can straight away substitute into my formula because it's given on the formula page. I want to find the sum of 42 terms as 42 becomes 42 over 2. 2a, my a is 3, plus my difference is 2, and I will have this as 42 minus 1 as I substitute. I simplify this one. I must get my answer as this gives me 21 there. If I simplify, 2 plus 3, 2 times 3 will give me 6, and then 2 times 41 will give me 82. This will give me 88. I punch this on my calculator. I'm doing the simplification to just show you that sometimes you just need to do some of these computations so that you are able to verify whether what is coming out of a calculator is correct or wrong. So it's 21. I multiply this by 88. I get 1848. That is the sum of 42 terms. My A and D 1 mark. Substitution, answer, I get my 3 marks. I will move on now to B. For my B, I have 2 plus 9 plus 16 plus until my last term, which is 1752. What do I have? I have my A as 2. I'm able to get my difference. They've already told me it's arithmetic. So 9 minus 2 will give me 7. But, so my D is equal to 7, but I don't have the number of terms. I must get the number of terms first. 1702 is my 1752 is my last term there. So I will use my Tn, which is A. I will do the substitution. 2 plus my difference is 7n minus 1 is equal to 1752, which is my nth term. I will simplify. 2 plus 7n minus 7 is equal to 1752. 2 minus 7 gives me negative 5. It goes that side. I'll get 7n is equal to 1757. Algebra, divide both sides by 7. I get my n as 251. Have I answered the question? No. So for the number of terms, it's now 251. I must get the sum. I have my first term and my last term. I will substitute and get my answer as 220,127. I'm done with that question. We move on to the next one. C. We are given the sum up to n terms. The sum is 72,710. We need to calculate the number of terms. So We are given our Sn. Sn is equal to 72,710. Our A is given as 2. Our difference is equal to 5 minus 2, giving us 3. Our difference is 3 in this case. Let's check. We have that information. We substitute. We get our answer as that one. We simplify. We get our answer is 3n squared plus n minus 145,420. Standard form is equal to 0. We are now solving a quadratic equation. Now, I'm old school. I can factorize. This will be 3n plus 661 n minus 220 is equal to 0. From there on, I will get my n as 220, or my n is equal to negative 661 over 3. Now, let's check. But we know that our n has to be a natural number, so this one is not applicable. So our number of terms that have a sum of 72,710 with the first term being 2 and a constant difference of 3, we must sum up 220 terms to get a sum of 72,710 in the series. Now, for you, if factorization is a challenge, please use the quadratic formula. You just make n the subject of the formula. So using the quadratic formula, n will be equal to negative b. Our b in this case is 1, so it will be negative 1 plus minus the square root of 1 squared minus 4. Our a is 3 and our c will be negative 145,420 using the quadratic formula over 2 times 3. The calculator will do the job for you. You must get your n as 220 and your other n will be negative 661 over 3. Let's move along. We have looked at our arithmetic series. Let's now look at our geometric series. We know that in our geometric series or sequence, our Tn is given by ar to the power n minus 1, and we know that our first term is a, our second term, third term, and this becomes our Tn. We are going to multiply. Now, you must see the difference. In an arithmetic series, the derivation, you just reverse the order of adding the terms. But here, because you are involving exponents, you want to remove that exponent negative 1. You multiply each and every term in equation 1 by r. And that will give us, where we have a, we'll have ar, and you write it under the term that is similar to it in equation 1. Equation 1, you will see that term 2, the term, this one, if you multiply it by r, it will be ar squared. You write it under term 3 because they are now the same. You do the last term and the second last term will be that one, and you will have that term there. So if you subtract equation 2 from equation 1, you will realize that it will be Sn minus r times Sn is equal to a. These ones will give us 0 because you are subtracting a similar term. This will give us, all this will be plus 0 plus 0. So there is no need for us to write plus 0 because it's a 0. Then we will have our Sn when we subtract minus r times Sn is equal to a minus a times r to the power n. Taking out a common factor, Sn 1 minus r will be equal to, we take out a is common again here, a 1 minus r to the power n. We make Sn the subject, we'll divide both sides by 1 minus r, we'll get our Sn as a times 1 minus r to the power n over 1 minus r. Now, there is a condition here, our r cannot be equal to 1, because if our r is equal to 1, we will be dividing by 0, which becomes undefined. So that condition has to always be there. And remember, this is also examinable. We must look at it again. Now, this is the first derivation. It's examinable, another 4 marks. So you must know the steps of deriving it, because if it comes, 4 marks in the bag. We move on to the next one. Here is another from another literature of how you can do the derivation. You, instead of subtracting equation 1 from equation 2, you change the order. You will find the formula that you get now. It's Sn is equal to a times r to the power n minus 1 over r minus 1. Now, this, I would say, people do not know which one to use and when to use which one. I always prefer to say, if you find your r, it's a proper fraction, use the first one. If your r is any other value which is not a proper fraction, remember proper fraction can either be negative or positive, but we know that the numerator must be smaller than the denominator. That's a proper fraction. But you can use it anyhow. You are using a calculator, it will always give you the answer. Now, here is example 3. It says, calculate the sum of the following finite series. In this case, it's not indicated whether it's arithmetic series or geometric series. But from the look of things, I can, because I know this is a geometric series, my term 1 for the first one, sorry, let me go back. So my term 1, my a is 1. I have to find my r. My r, term 1, term 2. So my r will be given by term 2 divided by term 1, which will give me 4 over 1, which will give me 4 as my r. The number of terms I'm given, the number of terms is 7. So it's a geometric series. My Sn is given by a r to the power n minus 1 over r minus 1. My sum of 7 terms, my a is 1, my r is 4 to the power 7 minus 1 over 4 minus 1. Use a calculator and it should give us 4 exponent 7 minus 1 over 4. And it should give our answer as 5,400 461. That is the sum of the 7 terms. B, we are given our series. Our first term is 2 over 3. Again, we must find our R. Our R is given by, it's easier to use term 2 and term 3. So if I use term 3 over term 2, because these are consecutive terms, I will get 6 over 2, giving my R as positive 3. Now, it means I cannot find the sum because I don't have the number of terms. I'm given the nth term. So I'll use Tn first. My Tn, it's A times R to the power n minus 1. I will be solving an exponential equation. So my A is 2 over 3. My R is 3 to the power n minus 1 is equal to 39,366. Now, 3 to the power n minus 1, I'm dividing both sides by 2 over 3. So I will have 39,366 divided by 2 over 3. I will get 59,049 from my calculator. Now I'm solving an exponential equation. Now, to get my n, I can either use logs or I can change 59,049 to base 3. And I can use my calculator. I have my value there, 59,049. I will use my calculator, shift 59,049 equals shift. I use that will give me my 3 to the power n minus 1 will be equal to 3 to the power 10. And bases are the same. I equate the exponents. I will get my number of terms as 11. Then I will evaluate as 11, which will be given by 2 over 3. 3 times 3 to the power 11 minus 1. All this over 3 minus 1. The calculator will do the job and you should get your answer. There is, you will simplify it later in the interest of time, but the steps, you are having them there. It's a matter of punching on the calculator to get the answer. We move on to the next one. We are given here, it's easy. It's already given. It's a geometric series. 5 plus 10 plus 20 plus. Determine the least number of terms for which the sum of the series will be greater than 5,000. Now, let's try and get what you are given. Our Sn must be greater than 5,000. What do we have? What information are we given? We are given that our first term is 5. Our ratio, this is our term 1, that's our term 2. So it's 10 over 5, and that will give us our common ratio as 2. We want to determine the number of terms for which the sum will be greater than 5,000. Now, how do we get the sum? Our sum is given by, we will have our sum as our A is 5, Our r is 2 to the power n minus 1 over our r is 2 minus 1, and this must be greater than 5,000. 2 minus 1 is 1, so it means we are left with 5. 2 to the power n minus 1 must be greater than 5,000. We divide both sides by 5, we'll get 2 to the power n minus 1 is greater than 1,000. We will get 2 to the power n must be greater than 1001. Now, we are going to use our calculators to help us get the value of n. N must be greater than the log. Our base is 2 of 1001, and we get our n must be greater than 9,97. If my calculator, so it's log, my base is 2, 1001. Yes, I get 9, n must be greater than 9,97. So, which is the smallest number which is greater than 9,97? My number of terms should be 10. So it means the sum of 10 terms is the one that will be greater than 5,000. These are common exam question papers. Our algebra must be okay so that we are able to do our sequences and series, because we apply a lot of algebra here, so we need to make sure that we practice our algebra. We move on. For our geometric series, we have what we call a sum to infinity. You will realize that if we are adding our terms that have a constant ratio, which is a proper fraction. As a proper fraction, we mean it is between -1 and 1. You will find out that the sum approaches a certain value. For example, the sum of one term there, if you're looking at that series, it will be 1. And then you add a half, it will be 1,5. You add a quarter, it becomes 1,75. You add 4 terms, you get 1,875. You add 5 terms, you get 1,9375. You add 6 terms, you get 1,984375. You continue adding the terms there. You will find out that the sum approaches a certain value and it will never go beyond that. Now, we say that our series converges to a particular value, which is the sum to infinity for that particular series. But if you look at our series to the right, here we got our r is a fraction, our r is a half. If you check on the other side, our r is equal to 2. And you will find as you add terms, the sum keeps on growing and growing and growing and growing. And we are saying, as the number of terms approach infinity, the sum of n terms also approaches infinity. It keeps on increasing. And we say the series diverges in this case. Now, the condition for convergence and divergence is that for a series to converge, our r must be a proper fraction between negative. It can either be negative or positive, but it has to be between -1 and +1. It's a proper fraction. The numerator is smaller than the denominator. Remember, if I have a fraction 3/2, this is not a proper fraction. It's an improper fraction because the numerator is bigger than the denominator. So please let us not make a mistake. because we'll just, once we see R as a fraction, then we'll say the series converges. The R must be a proper fraction. Let's check what we mean by that. Now, there is the condition. If a series converges, it will always have a sum to infinity. And we say for the series to converge, our R has to be a proper fraction. This is the condition. And our R, remember, cannot be equal to 1. And we are saying if it converges, it means the series will have a sum to infinity. And if we use our reasoning, we know that if I have my R, if my n approaches infinity, I know that R to the power n, because my R is a fraction, you raise a fraction to a big exponent, the fraction becomes very, very small. So in other words, R to the power n will approach 0. So if we are using the sum of n terms as a 1 minus R to the power n over 1 minus R, it would mean that this R to the power n, it's approaching 0. So it's as good as saying the sum of n terms. Remember, our n now is to infinity. R is to the power infinity. It will mean our sum becomes a. This approaches 0. It's 1 minus 0 over 1 minus R, meaning our sum to infinity, or our n is infinity in this case, becomes a over 1 minus R, because the fraction becomes very, very small. It approaches 0 in this case. Hence, we have our sum to infinity formula, which is given by a over 1 minus R, and our R must be a proper fraction. Let's check. Now, we are supposed to do example 5, the geometric series. Our first term is 36. Our term 2 is negative 18, and our term 3 is positive 9. It says, why does the sum to infinity exist for this series? What will you do? You evaluate your R, which will be given by negative 18 over 36, giving us negative half as our R. Ne? So from there on, you go to the condition. For our series to converge, our R should be a proper fraction. So if I check, my negative half is bigger than negative 1, but less than 1. So that is the condition. You evaluate your R, and then you show that your R is satisfying the condition for convergence. The sum to infinity, we are going to substitute. Our first term is 36. Our R is negative half. We will substitute there and get our answer as 24. So our sum to infinity will be given as 24. Let's move along. Example 6. You are supposed to determine for which values of x will the series converge. Typical exam question. How do we answer this one? We are having 3x as our term 1. 3x times x minus 2 is our term 2. And we also have our 3x times x minus 2 squared as our term 3. It just says for which values of x will the series converge. So we are saying for the series to converge, we must find our R. Let's evaluate our R. Our R becomes term 2, which is 3x x minus 2 over 3x. So that and that goes. We are left with our r as x minus 2. Remember the condition for convergence. It will be -1. In place of r, we substitute with the value of r that we got, less than 1. And this will now give us, to evaluate this, we add 2 so that we remain with x in the middle. So -1 plus 2 less than x minus 2 plus 2, 1 plus 2. And this will give us 1 should be less than x less than 3 for the series to converge. Now it says we are supposed to calculate the sum to infinity of the series in terms of x. So B, our sum to infinity is given by A over 1 minus r. Right? Sum to infinity, my A in this case is going to be 3x over 1 minus my r. In this case, it's x minus 2. And it will give the sum to infinity as 3x over 1 minus x minus negative, and a negative becomes plus 2. In which case, the sum to infinity in terms of x becomes 3x over 3 minus 1 plus 2 will give us 3 minus x. So your answer in terms of x, your substitution into the sum to infinity, and for simplifying the answer, you will get your 2 marks there. Hence, calculate the sum to infinity if x is equal to 2. Already you have your sum to infinity in terms of x. So if x is 2, it means where I'm having x, I'm going to substitute with 2. So my sum to infinity will be given by 3 times 2 over 3 minus 2. And my sum to infinity will be given as 6. We move on to the next part. So yes, we got that part. Now, we also have to look at what we call sigma notation. We have sigma notation for our arithmetic series and sigma notation for our geometric series. But basically, what is sigma notation? We want to write it as a summation. Sigma, it's a mathematical symbol, we know it. If I remember very well, for our statistics formula, we are given that x bar is given by the summation xi over n. So that's a summation sign. So it's not your first time to see sigma. We have seen it in our grade 11 work. It's not new. So it is used as a symbol for summing a series. And if you are given the summation from k equals to 1 of tk up to k is equal to n, it means you are summing. Where there is k, you are going to substitute. Our k is from term number 1. So you are summing the terms from term 1 up to the nth term. That will give us our sum. And it's read as the sum of all terms tk from k is equal to 1 to k equal to n, where n is a natural number. Now, so sigma notation is the sum. So what do we normally do? It's either we'll be given a series in sigma notation, or you'll be given a series and you are supposed to write it in sigma notation. So if you're given the series in sigma notation, just first of all, substitute the values of k so that you determine the type of series that you are working with. From there, you apply the sum of n terms of the given series. If it's arithmetic, you use the sum of n terms of an arithmetic series. If it's geometric, you use the sum of n terms of a geometric series. And it's nothing new. You shouldn't be scared. Let's look at our example there. It says calculate. You are given the series in sigma notation. What should I do? As I indicated, m is equal to 2 up to 50. Now, 5 minus 2m. For me to get the first 3 terms or so, I will substitute 5 minus 2. In place of that one of m, I'll put 2 plus 5 minus 2 times 3 plus 5 minus 2 times 4. I want to use that space, plus the last term will be given by 5 minus 2 times 50. Let me get my series. This will give me 5. This gives my term as 1. The second term becomes 5 minus 6, which will give me negative 1. 5 minus 8, it will give me negative 3, plus 5 minus 2 times 50, it's 5 minus 100. It will give me my last term as negative 95. Now, I must get the sum here. So for me to get the sum, remember I must get the number of terms. So it is important to always know how to get your number of terms. We know that always it will be given like this. We have k equals something here, and we have our top value here. So to get the number of terms, it is always equal to get n, we are going to say the top value minus the value at the bottom, we add 1. So to get the number of terms for this series, it will be n. Our top value is 50 minus the bottom, which is 2, plus 1, which means we are going to have 50 minus 2 is 48 plus 1, our number of terms. It means in this series we are going to have 49 terms, and we have to find the sum of 49 terms, in which case I will write this as follows. I will write my series m. I've ascertained that my series is arithmetic. If I check, this is my term 1, term 2, term 3. This will be my term 49. Let's find the difference. Negative 1 minus 1, it will be negative 2. Negative 3 minus negative 1, we get our difference as negative 2. So now I will have m is equal to 2. I will have my 50 there. 5 minus 2m is equal to, I will substitute into my sum of n terms of a arithmetic series. My n is 49 over 2. In this case, I was able to evaluate my first term, it's 1. My last term, negative 95, so it's 1 minus 95, which will give me 49 over 2. You can use your calculator now. Negative 94. So the sum of 50 terms will be given by we should get our sum as we should get this as m equals to 2, 5 minus 2m. I got negative 2,303 as my answer. So that's the sum of our series. Now, even if you use n over 2, 2a plus n minus 1 times d, it will give us the same answer. So you shouldn't be scared of sigma notation. Just substitute, expand. Like I indicated, our algebra needs to be 100% for us to get these marks well. Let's move on. I will do example 8. I'll only do one in the interest of time so that we can get time to practice activities as well. Now, we are given a series. Now, if you check this one, it has exponents. Once you see an exponent, chances are it's given our series is going to be a geometric one. So what are we doing again? Where there is I, we are doing our substitution to get the first 3 or so terms. Then we use those terms to help us get the sum. Now, it means for this series, I will have I is equal to 0, 19 up there, 3 times negative 2, I minus 1. So I will have this one, 3 times negative 2, 0 minus 1 plus 3 times negative 2. The next digit after 0, it's 1 minus 1 plus 3 negative 2. I will have 2 minus 1 plus up to. So this will give us the first term. Anything raised to the power, we have 0 minus 1. It gives us negative 1. So this will give our first term as negative 3 over 2 plus. Let's get that one. We will get 3. This becomes negative 2 to the power 0, which is 1. We leave it there. The next term that we are going to have, we are going to have 3 times 2 minus 1, we'll get negative 2 to the exponent of 1. Sorry, it's positive 1. It's negative 1. 2 minus 1 will give us 1. So exponent 1, and that will give our next term as negative 6. Now, this is our term 1. This is our term 2. That's our term 3. What do you realize? Our first term, A, it's negative 3 over 2. Our R, 3 divided by negative 3 over 2 will give us our negative 2. So how do you find the number of terms? Our number of terms, it's upper minus bottom. So it's 19 minus 0 plus 1, which means we are having 20 terms. Now we want to find S20 of a geometric series. So S20 becomes, we will get this as our A is negative 3 over 2. Our r, it's negative 2 to the power 20 minus 1, all this over negative 2 minus 1. We should get our S20. Please punch in your calculators. You will get your answer there as a positive value. I will not do the second example there, where we are given a sum, but the principle is the same. So in this case, you will substitute k is equal to 1. You are having a sum now. You have to get the number of terms. Now, we are also expected to know how to write our series in sigma notation. So when you are given a series like this one, write the following series in sigma notation. What is the first thing that you do? You investigate the type of series that you are working with. Our A is negative 4. If I check 3 minus negative 4, it's 7. 10 minus 3, it's 7. So in this case, I realize that this is an arithmetic series. First term negative 4 with a difference of positive 7. Now my Tn will be given by a plus n minus 1 times d. So in this case, negative 4 plus 7n minus 1 is equal to my Tn. I will get negative 4 plus 7n minus 7 is equal to Tn, and that will give Tn as 7n minus 11. From there on, we have to get the number of terms. To get our number of terms, our last term there is going to be 36. So 136, so I will put 136 here is equal to 7n minus 11. This will give me 147 is equal to 7n, and I will get my number of terms as 21. So I can now write this one as negative 4 plus 3 plus 136 is equal to, in sigma notation, where did I start? I will start from k is equal to 1 to 21, 7k minus 11. If you check, when I substitute 1 there, I'll have 7 minus 11, which gives me my negative 4. When I substitute 2 there, 7 times 2 is 14, minus 11, I'll get my 3. So I'm able to get my series. So it must have an equal sign. Sigma notation, I can do that, or I can find the sum of these and equate it to sigma notation, depending on how I'm asked to give the answer. But generally, I'm just writing this series in sigma notation. It will be given as our upper value is 21, lower value k is equal to 17k. Here we put our general term, then we get our solution. Now, let us quickly answer activity 2. I will give you 5 minutes to try activity 2. Welcome back. I hope you have practiced as well. We are given, consider the series -3 plus 5 plus 13 plus 21 plus to n terms. So, determine the general term of the series. Now, the same knowledge we have done with our sequences. This is our first term, second term, third term, fourth term. Term 2 minus term 1, we get positive 8, 13, 8. So we are able to see that our difference is 8. Our first term is -3. So which means our nth term, which is given by tk, will be 8k minus 11 after substituting and simplifying. Now, the next question, we are supposed to write Sn in sigma notation. How do we do that? We have our general term. So to write this in sigma notation, it's an arithmetic series. So we know that our first term will be given by k is equal to 1 up to n, 8k minus 11. Where we have tk, we put our general term, and that will give our answer there. But remember, it must have both the left hand side. So this is -3 plus 5 plus 13 plus 21 up to n terms is equal to that. So you'll get your 2 marks there. And then show that Sn, the sum of n terms in terms of n, will be given by 4n squared minus 7n, and that's 3 marks. We have our general term, but we are going to use the formula for Sn. We substitute. We do not know our n, but we know our difference. N over 2, -6 minus n, that will give us -14. From there, you are simplifying the algebra. It will give our Sn as 4n squared minus 7n. 2 into 8, it's 4. 2 into 14, it's going to give us 7. Then you are left with n times 4n minus 7. You multiply with this n, you get 4n squared minus 7n, which is what you are supposed to get. Substitution, simplification, answer. We move on to the other concept that I explained earlier on. If this is our term 1, that's our term 2, that's our term 3, that's our term 4. Remember, the sum of n terms, I said the sum of one term is equal to term 1. The sum of 2 terms becomes the sum of 1 term plus term number 2, because where there is term 1, I will substitute it with S1 and I get S1 plus T. The sum of 3 terms becomes the sum of the first 2 terms plus term number 3. The sum of 4 terms becomes the sum of 3 terms plus term number 4. The sum of 5 terms will be given by the sum of 4 terms plus term number 5, like that. If we generalize this, we'll have Sn. This and that are the same. That one, it's n minus 1 plus Tn. When we rearrange this formula, we are able to get whatever we want to get. Tn will be given by Sn minus Sn minus 1. This means to get term number 5, you must get the sum of 5 terms and also get the sum of 4 terms. You subtract the sum of 4 terms from the sum of 5 terms to get the value of term number 5. Now, this is what we derived, and we can use this in any question. There are questions where you'll be given, like our A, the sum of n terms Sn is given by n squared minus 2n. Determine the sum of 12 terms of the series. So it means if you want S12, where there's n, you're going to substitute 12. It becomes 12 squared minus 2 times 12. And this will give us 12 squared is 144 minus 24. It will give us 120. Substitution, answer. You have your 2 marks. To answer B, we are supposed to determine the 12th term. We want to find term number 12 is equal to sum of 12 terms minus the sum of 11 terms. We have calculated the sum of 12 terms. Let's calculate the sum of 11 terms, which will become 11 squared minus 2 times 11. And that will give us S11 will be 121 minus 22. And this will give the sum of 11 terms as 99. So to find term 12, it will be my S12. I calculated it in A and I got it as 120 minus 99, which means my term number 12 will have a value of 21. Like that. So this is how the sum formula works. Substitute. If it's consecutive terms, you get consecutive sums. Subtract to get the term that you need to get. Now, you will do this activity when you get home. It's from the November 2019 paper 1, question number 2.2. You will do it when you get home. Now, in summary, whenever we're working with patterns or series, one must know the type of a series that you are working with, whether it's an arithmetic, geometric series. We do not have a quadratic series. We only have an arithmetic series and a geometric series. And in most cases in the question, either they will state the type of a series or you have to investigate if you are not given. So the constant difference or the constant ratio, if it's an arithmetic, we must get a constant difference. If it's geometric, we must get a constant ratio, and we use the correct formula to determine the sum. In an arithmetic series, we always have a finite number of terms. We know the number of terms. But in a geometric series, we can have an infinite number of terms, and we have to evaluate the sum to infinity, and our series will be convergent. Sometimes we have a divergent series. If it's convergent, it will then have a sum to infinity, and our R must be between -1 and 1, a proper fraction. Application questions, we did not get a chance to address them, but we need to look at them where we apply our knowledge of sequences and series to solve word problems that just need the application. You read the scenario, you determine the type of a series that you are working with, get the sum or whatever you need to get. The examiners like those. And they are normally 6, 7 or so marks. If they come, we need to go over them again. We did not get a chance to look at application questions here. Now, I have attached worksheets to help you practice, and you see the type of questions that come under what we covered today. February-March 2018, paper 1, question 3. You also look at November 2017, question number 3. You also look at our November 2018, paper 1, question number 3. as a way to practice. And we also look at the June 2023 paper 1 question number 2. We need to practice those kind of questions, and I wish you all the best. I thank you. Have a good day.